Right. So far in the course, we have looked at the language of electrostatics. We understood how fields are created, and we looked at a new way of looking at fields through their fluxes and how they create electric potential in space. Now let's start putting real materials in and see how fields and charges would interact with these materials. The first material we're going to take is the conductors. A conductor, like a metal, gold, aluminium, copper, is basically a crystalline, highly ordered crystalline structure where the atoms are arranged in a very, very specific order, and the electrons which are surrounding the atom, at least in the last conduction bands, those electrons are very weakly tied to the atom. So if I go and I apply an external electric field to this material, which is what you have been effectively doing in ECE 140, if I apply an external electric field to this material, these electrons are very, very weakly tied to the atom. They feel the force and these electrons start moving. What we want to understand in this chapter is what would happen in equilibrium. We are applying this field to this conductor and we want to understand what would happen once all this motion has finished. Where would these electrons end up? What would be the field looking like inside? What would happen to the potential? What happens if I give some extra charge to the conductor too? In the first half of the conductor part of this chapter, we are not going to put any excess charge on the conductor. This conductor is neutral, has the same number of electrons and protons. So, the total charge on the conductor is going to be 0. However, because electrons are very weakly tied, we can easily distribute the charge. We can easily move this charge around when we apply an external field to this conductor. For all of this chapter, we are going to assume that the conductors are ideal. Later on, probably in week 7, we will add the non-idealities in the conductor, which is effectively your resistance. For ideal conductors, the assumptions we are going to make that there is no resistance to the motion. There's absolutely no resistance to the motion of these electrons, which basically means that if I make a wire of this ideal conductor, the resistance of that wire would be 0. And this is the same assumption you have in ECE 140. When you are doing analysis in ECE 140, you have a source connected to a resistor. You assume that the wires you're connecting to the resistor, they don't have any resistance to them. So that's one of the conditions we are going to put on this conductor or the ideal conductor. The second condition is that there are almost very large number of these electrons present, and the conductor will never run out of them. And no matter what is the strength of the external electric field I apply, the conductor would have enough charges that these charges start to move and obey the rules we create here. That we are not going to create any, that these conductor which we are going to test would never run out of electrons. If I increase my electric field, it would still be able to move more electrons through. And that's a very good approximation for most of the work we do in our field. And the third condition we are going to put for ideal conductors is this. Let's say I have a conductor. I apply an external electric field. The electrons in the conductor are going to start to move out of the atom and they will start to hop around. But the condition we are going to put is that these electrons will not leave the conducting surface. That the maximum these electrons can go to is the surface of the conductor, that they would never leave the conductor out of it. So the electrons will only move till the surface of the conductor. And that surface, we can assume it to be nearly atomically thin, and all the electrons which have to gather would gather at that surface. And when electrons move to one side, they would leave vacancies on the other side. So I would end up getting some negative charges here, leaving some positive charges on the back side. These are the three conditions we are always going to assume in this chapter, that the conductors have these three properties as we try to understand what happens when I put these conductors in external electric fields or I put some extra charge on these conductors.